Just a quick look at what we've done so far. We looked at 8A, effective interest rates. This is the rate of interest that you will get when interest is compounded more often than once a year, for instance quarterly, monthly, weekly or daily, and it means that if you're borrowing money it's going to cost you a bit more than the quoted rate, the nominal rate. If you're saving money you're going to earn a bit more than the quoted or nominal rate. The way to do an effective interest rate calculation is using your graphics calculator, apps, finance, and then find effective, which I think is after 9 it goes ABC. Then we looked at 8B, compound interest, using TVM solver. This is just another way of calculating compound interest without using the written formula, and you're using TVM solver. If you can't remember how to use that, then refer to the video I made for 8B. And just remember that it's just a straightforward compound interest calculation, so the loan or the investment is not being repaid or paid out during the term of the loan, it's just right at the end. So now moving on to 8C, modeling compound interest loans with repayments, with periodic repayments. So if it's a loan, you're paying it back over the term of the loan, 2 years, 5 years, or whatever it is. In 8C, we'll just look at simple loans which are all repaid by the end of the term, 2 years, 5 years, or whatever. So let's look at question 1 of the exercise, which goes like this. A student borrows $2,000 at an interest rate of 12% per annum to pay off a debt. The loan is to be repaid by making 6 monthly repayments of $345. First thing is it's 12% per annum and it's being paid off monthly, so the interest will be added monthly, which means that the interest will be added 1% per month. That's the first thing that you need to calculate. Putting it in words, the loan will look like this. You start off owing $2,000. You then, after 1 month, you pay off $345, but you get 1% interest added. The following month, you pay off another $345. You get charged 1% interest on whatever the outstanding size of the loan is, and so on, which goes on for 6 months, by which time the loan should all be paid off. So just remember those figures. Loan of $2,000, 12% per annum, $345 repaid every month. Now I've got an ordinary calculator on the screen here. It doesn't have to be anything special. You put your 2,000 in like you did for recurrence relations before and press enter. We then want the previous answer. We have to multiply by 1.01 because that's 1% interest. That is a multiply symbol, that dot there, which is adding on the interest, and we have to take off the $345, which is the repayment, and that's your $675. If you look at question 1, that is the number in the table there. Copy that, paste it in there, gives me 1675, which is my new balance, times 1.01 minus 345 gives me 1346.75. Do it again. $1,015 left owing. Do it again. $680 left owing. Once more. And you'll see that we now only owe $342. It's never going to work out exactly, but the final payment will be $342.17 if the bank is tight. And that's how you do question 1. You can do question 2 later on. Moving on to question 3, this is a way of showing that what we've just done can be modeled by a recurrence relation, which we looked at in a previous chapter. So V0, the starting value of the loan, $2,500, and each succeeding term of the sequence is going to be, in this case, 1.08 times the previous balance. In other words, we're doing 8% interest and we're repaying $626 each term. So what you have to do is do the same as I did for question 1. They're all doing the same thing, but they're asking different questions, so make sure you answer each part of each question to fully understand the whole topic. On the screen now is the actual question from the textbook. We've already seen what the recurrence relation looks like. Let's now do what it asks you to do, which is to use a calculator to determine recursively the balance of the loan after 3 repayments have been made, giving your answer to the nearest cent. So on the left of the screen, first of all, put in your $2,500, the initial balance. Second function answer is down the bottom right hand of the calculator, times 1.08 for the annual interest rate of 8%, minus $626 for the repayment. Press enter, and that's the new balance after 1 year. Moving to the next screen, do it again, and the third one will give you 1117.03 to the nearest cent. So that's the answer to part A. Part B is the loan fully paid out after 5 repayments of 626 have been made. Well, after the 5 repayments, there's still a balance of 0.82799, so there's another 83 cents, which presumably the bank will ask you to add on to your last payment. Here's another question, similar way of approaching the problem. 10,000 is borrowed at an interest rate of 12% per annum, compounded quarterly, and of quarterly repayments of 2690.27. Now part A asks you to write a recurrence relation, so B0 is $10,000, comma, remember, and then B n plus 1 will be the rate, which is 3% each quarter, so 1.03 times Bn, so the previous term, minus D, which is 2690.27. Put the money into the calculator, $10,000, enter, answer times 1.03 minus 2690.27, enter, will give you after 1 year, and this one after 2 years, which is the correct answer. 2 more payments. There's only 0.2 of a cent left, so that's effectively paid off. So all the questions are similar. If you can do that, you can consider compound interest problems as recursive functions and solve the problems. Over to you now to finish the remaining questions of 8C.